Hello again, Demonari here back doing some nonsense. This is a video about the Chip-8 and how it's a very good introduction to emulation. Because unlike most real emulators, basically running Chip-8 ROMs works the same as running ROMs from real emulators, as your virtual machine basically needs to function as a bridge between the real hardware and the simulated hardware. This is basically fake machine that has some specs and certain opcodes for machine instructions that basically simulate exactly how a CPU would function. It's also extremely easy to understand. Opcodes are 16-bit, and the first nibble, basically first 4 bits of any opcode, is a very good descriptor of what you're going to do. The code itself. When I'm using this emulator, I'm basically just have this Chip-8 emulator data that reads the ROM. Then for sanity's sake, so I don't need to check the time in any stupid way, because SDL-get ticks gives me a stable time. C does have that, but you need to know that there are differences in the implementation between Linux, Windows, and everything else, and all of them return different types of time. This just returns milliseconds for everything. Input doesn't work in console mode because fuck implementing input in console mode, and then it redraws when it needs to redraw and run the ticks until stuff happens, then delay. How does it draw? It goes bit by bit and just draw the bit with printf, clears the screen, and then draw space with certain color or another. That's it. Super easy. Let's run it with the IBM stuff, and as you can see, it displays the IBM ROM v4.2, yeah, or the Pong, which displays like this, and then when the game starts, it's actually doing the calculation stuff. So yeah, just the BCD is not implemented because I couldn't find a specific way that implements the... Okay, so here, sprite address. Yeah, I couldn't find a way to do set sprite address properly, so BCD doesn't work, and it doesn't display the numbers themselves properly and certain other things, because the sprite address that is supposed to store font data is not set properly, so I couldn't do that. Back to the code. Now, this describes all of the stuff: the time frequency, the CPU frequency, sprite line, all of the stuff. Maybe I would want to change those later. Maybe there are some settings that might change. And this is the data. RAM is the RAM, keyboard is the keyboard, registers here, the timers, stack pointer, program counter, address register, the clock and tick timers, and the seed for random. Why do I have a seed for random? Because this thing has a random function. And it's not implemented here, but later on I did implement it using some stupid logic. Read-ROM just does this, zeroes all of the stuff, sets the program counter and the stack pointer to the correct location, and read from file. Read file up to does basically all of the sanity tests for stuff, and then reads a certain amount of bytes until it gets to the end of file into the memory. That's it. Instruction from address basically takes the RAM address and it constructs it into a short that was stored in big endian. Parse instruction gets instruction from address, advances the counter pointer, then it calculates the timer tick. If the timer tick is different from the previous timer tick, it sets it and does the ticks. for sound and delay, which are basically synchronizes it to run the correct tick perfect updates for stuff that uses the sound and delay functions. The instruction is reading the final nibble from the instruction, then shifts it. Okay, so 0 instructions, basically just stuff that is system calls and stuff like that. Anyways, 1 instructions, program counter, this basically go to call instruction, 3 instructions, find which register from this nibble, then gets the value from this byte and does the if register of that is equal to the value. Then jump over. Same here, but now it's different. Now it's taking 2 registers. Now it's setting the register to the value. Now it's adding without using any of the ALU functionality. Now it does the ALU. Then it does the if not equal. Then it does the set address register to the value. Then program counter go to that specific location, then does the rand, basically just calls rand with the value, then does this, the draw with the values that it needs, and all of the other stuff, the E instructions for keys, and the extension. Extensions, the get delay, get key. Is it get key? Yeah, it is. This is a get key that is locking. If there is no key value, it decrements the program counter to repeat the instruction until there is a key pressed. And when there is a key pressed, it stores that value. Then there is a delay timer, setting the delay timer from a register, setting the sound timer from a register, adding into incrementing address register with register. As I said, not implemented because I couldn't find a specific location where sprites are stored. Setting BCD and register dump and register load. All of them are very, very easy. LU just does all of those things, and then flag register is interacted with. It is set after, because that's the documentation for that. So all of those things are done. There is basically a different interpretation of this instruction, and yeah, I just allow both. Read reg can be this or that, and that is how it's going. Okay. Push stack just puts the address into the stack pointer so that it can be read, and then read it. And instruction from address, you decrement the stack pointer unless it's the start of the stack, and then return the address. If the address returned is -1, because there is no address, then the function itself returns and stops the emulator, and it can be seen here. Address pop stack, if -1 address, exit. Otherwise, program counter equal to address and return 0. Call stack, push stack, program counter. If stack end, meaning stack overflow, return 2. And this would exit the operation. This would stop the operation of the emulator again. Program counter equal address if everything goes right, and return 0. Clear display, just take the display and memset to 0. Draw at does the drawing logic. It is not that easy to explain, but basically it's just taking 8 bits in any position and bleating them, basically XORing the operation, using the operation XOR to bleat those into the correct location. If old end display is not old, meaning that there was some bit collision, then the F register is set to 1. This basically checks if any bit got turned off during the bleating. This happens here as well for the unaligned bleating, but now it goes with the first bit, with the first byte, and then the byte after it, so that it can perform all of those operations properly, even when the X pixel is not divisible by 8. Then rand not implemented, get key press just looks at the key, and if it's equal to 2, which means it was set in the stick, it returns the key index, which starts with 1 index and not a 0 index. Yeah, don't ask me why. And that is the entire implementation. It's like, what, 480 lines. This is less than 500 lines of code. Quite a bit of it is new lines and just comments. So yeah, they implemented most of it. Now I can go over this. This is a Chip-8 emulator that also renders the... Oh, I forgot that I added this music. That's so stupid. Let me turn that off. I completely forgot about that one. Yeah, volume 0. I did some testing with my sound manager and now it was very funny. Okay, now let me add source here because and now this should be visible. Yeah, so this, thank you, ROMs IBM Chip-8, and then I do load and I can load this. And if I set those keys, I can do one player Pong, change it into the go-to display, load, and now everything works except the score display and the middle line, because those are loaded from sprites and I don't know how to set that up because there was no documentation I could find for that, but there probably is. Just something like, oh, this is the way that you implemented in legacy version, and this is the way that you implemented it in this version, and stuff just doesn't want to work properly. Also, ever since I implemented rand, this thing is impossible to defeat. Like, completely unbeatable. It just always tracks it perfectly. It's not that difficult. The logic itself, this is a lot of rendering stuff. But basically you just load all the bits into the stuff. This is the loading function that I cleaned up in later versions of my engine to make it a lot cleaner. The renderer is actually very simple. And all of this is for the UI. And just this renders the screen. Update. Oh, right, there is some stupid thing I did so that if I want to output the actual glyph atlas, I can do that, but the screen itself is hiding it. So yeah, this is this logic. if I ignore this logic, there is the text box, and yeah, everything is extremely simple logic. Input, same. Most of it is very simple logic. So there is no... Yeah, I did rework the engine. I did do a lot of cleanup in the back-end code for it and separated a lot of stuff. I think that half of this... No, everything except texture was in two files. One file... No, it was in one file. All of those except texture were all in one file. So now there is a lot smaller stuff here that's just easier to understand. Texture now has update pixels, make raw, that actually takes like easy stuff, so I can make different types of textures. Render subsurface and make from surface. Render subsurface is somewhat useful. Yeah, added a lot of stuff that just quality of life and simplification. This is still in the works. It's basically changed the emulator to be a general purpose one, and then took the Chip-8 implementation from the previous thing and re-implemented it. Here is the new random function. You should know this random function if you know a little bit about PRNG. And this is actually a common PRNG implementation, so yay. And yep, the data stores and all of that. So yeah, this is the Chip-8. This is a little bit of an update on my engine, and that's all.